Hello, geometry students. We are going to collaborate on a video this time for a little bit of review. Rather than take the quiz on Friday, we're going to move the quiz till Monday and use this little review as a way to review some things from the last quiz and also to prepare for the next quiz. I just realized that I made a cursive G. I'm not sure everybody understands that. So I'm going to make it a regular G so you understand you are watching the correct video. This is geometry. So we're going to use blank paper, and I want you to sketch this exact picture, which means two parallel lines cut by a transversal. And I want you to mark this one, 3x minus 1, and I want you to mark this one, 2x plus 25. Pause the video until you have that drawn. So what you should notice on this problem is that you have a pair of angles right here, and I want you to tell us the name of that angle pair. So based on your answer to the angle type, let's set up a relationship here. This angle and this angle are both acute. If you were to look at that angle and also look at that angle, that was intended to be the same, then you would know that they are equal. So we'll set them equal to each other to solve for x. So hopefully that was your work and that was your answer. X equals 26. The next problem will be presented by my colleague, Dr. Conklin.
Thank you, Mr. Keel.
Not a problem.
All right, we are going to look at this problem next and look at the two angles we have here. So very similarly to what Mr. Fields just said, we're going to ask you guys to think about what's the relationship between these two angles that we have information about.
First, let's have them draw them on their blank paper.
Oh, right. Perfect. Thank you, Mr. Fields. All right, so please draw this on a blank piece of paper. And then think about what's the relationship between these lovely angles here. So just as Mr. Fields talked about, if we look at this angle here and this angle, we can see that this guy here is acute and this is obtuse, which gives us a really big hint. Hopefully you realize that these are same side interior, but if you didn't, the bigger hint is that these two angles are definitely not congruent. So you have a small angle on top and a big angle on the bottom. So our rule says that we are going to add the two angles up for same side interior and set them equal to 180. All right, we're back. If you did all this work, you should get y equals 24. Now, what we noticed on our last quiz was a lot of folks had a hard time with this right here, the measure of angle x, y, z. So do not think that you're done right here. You have to keep going. So I'm going to take x, y, z. It's a little tricky, guys. Is not one of the angles that we're given. It is x to y to z. It is this angle right here. So I'm going to put a little question mark here. How are we going to find that? Well, we know what y is, so we can go back. Sorry, I have to get rid of all these extra lines. And we can substitute in. So 3, I don't think I should remove that, but I'm going to. Nope, it won't let me. So 3 times 24 plus 10. Little quick math there, that should be 82 degrees. Now, in order to find the angle that we're missing, I'm going to do my little swoop. I have a semicircle there. And so I can take, I'm running out of room here, guys. This is a great regions question. I'm going to subtract these, and 98 degrees is our angle, which if you check back up, this does look up too, so that's 98. All right, we have another question here. I'm going to pass this off to my other wonderful colleague, Miss Bella.
All right, everyone. So now we are going to take a look and draw this diagram to start on your paper. And what we are going to do here is find the measure of angle OPK. So first, let's identify which angle that is. So I'm going to trace angle OPK. So the angle that we're looking for is this one right here. And what I want you to notice, this is the exterior angle in our triangle. It's outside of our triangle. So what we know when we have an exterior angle, if we look at the two remote interior angles, the two angles that are inside our triangle that are furthest away from our exterior angle, we can add those together to get angle OPK. So for this problem, all we are going to have to do is set up an addition problem of 82 plus 40 to get the measure of our exterior angle. So for this problem, we should get 122 degrees.
Welcome back, everybody. It's Mr. Fields. You might remember me from the first problem just a few minutes ago. So take a minute to draw this triangle and make sure that you have, that's a little bit large, just a sec. Make sure you have that this segment and this segment are equal, making that a midpoint, and make sure you have this segment and this segment being equal, so you have another midpoint. And what looks to be a mid-segment is called 2x plus 10, and its parallel bottom is 5x plus 8. Okay, now that you have it drawn, I'm going to give you a little hint, I like to say, with mid-segment problems. You want to double the smaller one. Because if you set up an equation like this, 2x plus 10 equals 5x plus 8, that wouldn't be true, because there's no way that this little thing is the same length as that big thing down there. We know that it's double the smaller one. So if we take 2 and multiply it by the smaller one, now it's accurate. It takes 2 of these. So it takes 4x plus 20 to equal 5x plus 8. So go ahead and solve for x. But be careful, you're not done. The question said find side CZ. So after you find x, plug it into CZ for your final answer. You'll notice that x was 12 algebraically, and when you plugged it into the 5x plus 8, side CZ came out to be 68.
Hi guys, this is Dr. Conklin back again, featuring some music that I helped collaborate with a friend on. I'm not sure if you guys know this song. Mr. Fields, do you know this song? Irreplaceable? Have you heard this before?
Who is this, Garth Brooks?
Yeah, that's right.
Yeah,
Very good.
I've heard of it.
Miss Vala knows. All right, so again, please draw this picture on your piece of paper. We see we have two little friends here. We're not going to take time to put that information in unless you really need to know it. So let's review this. We have one side here and one side here that are congruent. Making this, I'm going to write it out for us. It's hard to say. Isosceles. Miss Vala, let's say it. Isosceles. Which means we have two congruent sides and two congruent angles. This is our vertex angle, since the two congruent sides are touching, which means our base angles are down here. So go ahead and get going. Okay, our base angles are always our congruent angles. Okay, now, so since this is 29, this guy over here is also going to be 29 degrees. Now, don't get fooled by this. What did we ask you to find? S to G to D. So I'm going to just take a little highlighter here, show you guys. S to G to D. So you might try to find the vertex, but we need you to find this angle over here. So since we have a straight line here, we can do 180 minus 29, which should be 151 degrees. And just checking our work, does this look like it could be a 151 degree angle? Yes.
I think so.
What do you think, Miss Vala?
I think so. Isn't that obtuse?
Oh, no, she didn't.
That's not very nice.
All right, back to you, Miss Vala.
Hi everyone, Miss Val is here. So for these last two questions, we're actually going to review with you the Pythagorean theorem, which the Pythagorean theorem you might have learned in the past. It's this little formula, a squared plus b squared equals c squared. Now, what you have to know before you plug in any numbers is c in this formula is what is known as our hypotenuse. So this is our hypotenuse.
I don't think I can spell it, Miss Val. I just want to say. You got that.
I tried.
You
I
go,
hope
girl.
I did it correctly.
You go.
So our hypotenuse is the side opposite our right angle. So here is our right angle. The side opposite would be right here. And that is the value we are going to plug in for C. So, and the other two don't matter as long as they go in the spots for A and B. So I'm going to say 9 squared plus 13 squared equals our hypotenuse, which is x squared. So now I'm going to simplify the left-hand side. So 9 squared, 9 times 9 is 81. 13 squared would be 169. And now before I can solve for x, I have to add those together. So we get 250 equals x squared. And now to get x by itself, remember that we have the squared here that we have to get rid of. So what are we going to do? We are going to take a square root on both sides of our equation. Remember, whatever we do on one side, we have to do on the other. So what we want to focus on with our square root here is to break up 250 into two multiples, one of them being a perfect square. So 25 is a perfect square, and 25 times 10 gives us 250. And now, what number can we multiply by itself to get 25? That would be 5, so our answer should be 5 square root of 10.
Last question. Last
Yay!
question. We got this.
All right, last question here. Very similar. The only difference is this time our unknown side is not the hypotenuse. Notice these two sides here in red are the legs of our triangle. So we're going to go about this the same way, using a squared plus b squared equals c squared. We'll plug in 5 for A and x for B because our C value, our hypotenuse, is 13. It's across from that right angle. So now we have 25 plus x squared equals 169. So here we're going to subtract our 25 to the other side. We have x squared equals 144. And now this time when we go to take our square root on both sides, 144 is a perfect square. What number can we multiply by itself to get 144? That would be 12. And there you have it. That is your review for Monday.